Hello, my name is Dr. Michael Atkin, and welcome to the Technology Leaders Lounge. I'm an assistant professor at Kansas State University, Salina, and in this series we explore new technologies and emerging technologies and talk to some of the people here at K-State Salina that are involved with these. Today I've got Michael Moran. He is a grad student in our Integrated System Design and Dynamics degree program. So Michael, welcome.
Thanks for having me.
Yeah. Today we're going to talk about some interesting topics, things like VR, virtual reality, augmented reality, all those different kind of new immersive technologies. And so, Michael, I know that you are really working on some cool projects and things with different XR technologies. So one that I wanted to talk about today was a cool project that K-State Salina started about a couple of years ago with the United States Air Force Academy. And I know you were involved in that. And if you kind of tell us a little bit about that project, and I know we have some of the technologies here and kind of what you're doing with that project with the Air Force Academy.
So it actually started my senior year in the CMST program. It was our senior project for graduation. And we basically got told that there was a collaborative project that we could work on with the United States Air Force Academy to create a virtual reality application that would be used in an educational capacity over at their university or college. Yeah. It's essentially just a virtual reality application where you can actually see real-time satellite data and locations, as well as maybe have a sandbox educational mode for instructors to show how those satellites move around the Earth.
Okay, cool. And so you said you're using VR, and we have a VR headset here. This is a MetaQuest device, and so maybe explain a little bit about how that works with using the VR device.
In relation to the project, we were developing it for the Quest 2. It would be using just the headset and the controllers. We hadn't figured out how to do hand tracking just yet, so we were just going to do controllers for the first few builds. Basically, a user would be able to put the headset on, go into the application, and using the controllers, they'd be able to move sliders to change the attributes and values of COEs, which are classical orbital elements.
Okay.
I can't remember all of the names of each of those factors off the top of my head, yeah. But there were 6 core features that you could change about a satellite's orbit, and it would change, the angle at which it's orbiting the Earth. It would also change how far away it is or how fast it was going. So it was pretty simplified in the app, a lot more simplified than the real life science behind it, but it would at least form an understanding of the basics for satellite orbit.
Yeah, so, and I imagine that provides kind of a much more immersive experience for the students and the educator. I'm guessing you kind of go into this VR application and you're kind of in space and you kind of see the Earth and you're kind of actually right there in that and see the orbit and probably, I'm guessing, get a better maybe feel for how things are moving and how they're situated above Earth and kind of orbit. Is that kind of the main goal of this?
Yeah, definitely. We also had a option. You could get closer and further away from the Earth to see different satellites because satellites are at different heights, and you can see the height difference between them, or I guess the altitude difference. Yeah. But there's also an option that you could get close enough to the ground that you could basically pretend you were standing on the surface and you could still see the satellites and how they would move through the night sky if you were looking at them from a certain location in the ground.
Wow, that's cool.
And we had a 3D realistic map of the Earth that we actually used. So when you hit the ground, you could actually see the 3D heights of things on Earth. So if you stood next to a mountain, it would go above you, next to you.
Oh, that's pretty cool. That's amazing. And I think that's, the kind of the magic of this type of technology is just having the ability to put people in situations and more immersive, environments than they normally could be in versus, just looking at a computer screen or a laptop screen or something like that. So I know you're working on your graduate thesis project, your master's thesis, and you're Are you working on this project for that thesis?
Yeah, so I'm still somewhat working on the project. Development has definitely slowed down a lot just because we were using our senior class in my undergrad as the development team. Our development team dropped down to about 3 people when we started our master's program, but since then a lot of people have split off of that project to do their own specific research for their degrees. So right now it's kind of slowed down in the development, but we do have a proof of concept at least at this point in time. And I'm actually going to be using that proof of concept in my research for my thesis, which is the applications of XLR technologies in military training and operations.
Oh, awesome.
So we'll be looking at, interviewing current service members in many branches of the military, and they'll be able to give feedback on, whether this application or, inferring things like it could actually be useful in training situations to prove whether vision could go forward as an educational product, or if it would be able to be applied in operations as well out in the field.
I really enjoy this technology. I've always been, kind of intrigued by its possible uses. So it'll be interesting to see where your research goes. And good luck with your thesis on that topic. So it sounds like it's going to be a really, really cool project moving forward.
Thank you.
Yep. Okay, stay tuned for more interesting technology topics within the series. So again, Michael, thanks for being with us.
Thanks for having me.
Okay, thank you.